we left off, we had basically taken our paper plate and cut it into quarters and then labeled the 45-degree angles that resulted. So what we're going to do now is the 90-degree angles that resulted. What we're going to do now is fold it again and do the 45-degree angles that result from the unit circle. So we're going to fold it back into quarters and then fold our quarter one more time. Make sure you crease it really, really well. So now I've essentially divided my paper plate into 8 equal sections. So we can flatten it out. And so what I'm going to do now is I'm going to trace along the folds, and I'm using a different color marker than I had before. I was using blue, and now I'm using purple. So I'm going to draw my diagonals here. And then we're going to label them both in degrees and in radians. So again, this is my initial side. This is where the degree is 0. And so if you think about what I've done to this quarter of my paper plate, when I split it in half again, what was 90 degrees, if you think about cutting 90 degrees in half, that makes this a 45-degree angle. And if you think about cutting pi over 2 in half, half of pi over 2 is going to give you pi over 4. And so that gives me both the degree and the radian measure of this angle. Well, if you think about how wide this angle is, each of these measures is going to be 45 degrees. So this is 45 degrees. This angle is 45 degrees. If I add another 45 degrees, I'm going to get 135 degrees. If I add another 45, that gets me to 180, which I already figured out before. If we add another 45, we get 225. Another 45 I know is going to be 270. And then another 45 is going to give me 315. And 45 degrees more is going to give me 360 degrees. And then I can do the same thing with my radian measure. So I know that each of these 45-degree angles also is going to correspond to pi over 4. So if I just count by pi over 4, I know that this next angle would be 2 pi over 4. And then the next one would be 3 pi over 4. The next one would be 4 pi over 4. Well, notice 4 pi over 4 just reduces back to the pi that I had there originally. The next angle would also be 5 pi over 4, 6 pi over 4. And if you think 6 over 4 is going to reduce to the 3/2 pi that I already had before. So that's 6 pi over 4. This is going to give me 7 pi over 4. And then I'm back to my initial side, which is going to be 8 pi over 4. And 8 pi over 4 reduces to 2 pi. Okay, so that gives us all of our 45-degree angles. The other common angles in a triangle would be the 30 and the 60-degree angles. And so we're basically going to fold our paper plate again, but instead of taking those quarters and folding them in half, we're going to try to fold them in thirds. And this is a little bit more awkward because now the paper plate is kind of thick. Just do the best you can to fold it into thirds. And then spread it out. And I don't have another color marker, but it would probably be a good idea to use a different color marker when you're doing the 30 and the 60-degree angles. Now, the fold isn't quite as, or the crease isn't quite as tight as the other ones. It might be a little bit harder to figure out. And it's okay if it's not perfect. I mean, the idea is that they'll understand the degrees. So basically, if I think now about my first quadrant and what I've done with these new folds, I've essentially taken 90 degrees and split it into thirds. So that means that this angle is now 30 degrees, and the next one is going to be 60 degrees. The next one will be 90, and then if I keep going, this will be 120 degrees, and then I'll go to 150 degrees. The next 30 degrees will be 180, and then I'll be at 210 degrees. If I add 30, I'll be at 240 degrees, and then at 270, this is going to be 300 and 330 degrees. Oops. And then you can go back and do the same thing with your pi values. So if you think about my top half of my circle was a whole pi, And by cutting each of the quadrants into these thirds, I've basically divided the top half of my pie into 6 equal parts. So this angle is going to correspond to pi over 6. The next 30-degree angle would be 2 pi over 6. Well, 2 pi over 6 reduces to pi over 3. And then my 90-degree angle would be 3 pi over 6, which is pi over 2. This would be 4 pi over 6. Well, 4 pi over 6 reduces to 2 pi over 3. This is going to be 5 pi over 6. 6 pi over 6 reduces to pi. 7 pi over 6. 8 pi over 6. Which is actually going to reduce to 4 pi over 3. And then 9 pi over 6 is going to be the same as my 3 pi over 2. And then I have 10 pi over 6, which is 5 pi over 3. And then lastly, 11 pi over 6. I think I said that wrong. But anyway, you're just going to count by pi over 6. And then a real quick way to explain the conversion from degrees to radians. If you think about the top half of your circle, it's pretty obvious that 180 degrees is equivalent to pi. So if you think of it this way, 180 degrees is equal to pi radians. If I want to figure out the conversion, what I can do is divide both sides by 180. When I do that, the 180s cancel, and I find that I have 1 degree is equal to pi over 180 radians. And we can do the same thing by dividing by pi. So again, if we have 180 degrees, and that equals pi radians, if I divide both sides by pi, then I get that 1 radian is equivalent to 180 over pi degrees. And the easiest way to remember that, for example, like let's say I want to convert 90 degrees to radians. All of your radian measures are going to involve a pi. So if I have 90 degrees, it doesn't have a pi yet. So what I'm going to do is I'm going to multiply it by pi over 180 so that I get the pi. And so when I multiply, I'll have 90 pi over 180, which is just going to reduce to pi over 2. And likewise, you can go the other way. If you're starting off, for example, with, let's just do pi over 6. So if I have pi over 6 radians and I want to translate that into degrees, since I have a pi, I need to get rid of it. So I'm going to be multiplying by the 180 over pi. My pi's cancel. 180 divided by 6 is just going to give me 30 degrees. And that's it.